Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And a very lovely and good day I bid to Madam HALIZA KASSIM. I am Muhammad Huzaifah bin Yaacob from AS253S1 with my groupmate Muhammad HAIKAL bin NORAMRAN AS253S2, AMIRUL Ashraf bin Muhammad AS253S2, and DARRON MEDANG Anak Baring AS253S1 will introduce and present you about nicotine determination from tobacco products by gas chromatography mass spectroscopy analysis. As an introduction, this experiment was conducted to know the amount of nicotine, milligram of nicotine per gram of tobacco in 39 tobacco samples and products. In 31 cigarettes, 5 cigars, 1 tobacco pipe, and 2 tobacco leaves through the practical application of a validated GCMS method analysis. Next, we move to the importance of determining nicotine in tobacco products. As we know that nicotine is the major tobacco alkaloid with a proportion of about 1.5% of tobacco weight from commercial cigarettes and represents approximately 95% of the total tobacco alkaloids. And it may cause major intoxication by in one cigarette approximately 3 to 4 milligrams of nicotine pass into the airways, of which 19% are reabsorbed into the lungs. Thus, it is important to analyze nicotine in commercial tobacco products, in cigarettes, pipe tobacco, and tobacco leaves to know the amounts of nicotine milligram per gram that present in tobacco products by varieties of brands, either domestic or international, by using GCMS method. And last but not least, this is also an information to the public about dangers of nicotine addictions as it may affect to our health. Now we move to why GCMS method is chosen compared to GCFID, gas chromatography flame ionization detection. Nicotine is an alkaloid, and tobacco leaves were extracted with methanol dichloromethane 1:1 volume per volume. The detection limit for nicotine was at the ppm level for selective monitoring and the nanogram for selective detection. GCMS method provides advantages in high sensitivity, nicotine-specific detection, and lower instrumentation costs. Besides that, the detection with GCMS in selected ion monitoring mode is excellent in reducing signal interferences that can bias nicotine values compared to GCFID method, which is low in reducing signal interferences. On the other studies, GCMS method is chosen compared to GCFID because GCMS provides confirmation of chromatography peak purity in certain highly flavored products that GCFID method cannot provide. And lastly, GCMS also provides a method that is versatile enough to analyze a wide range of nicotine values in domestic and international samples of varying complexities.
So next, which is the method part. The samples of tobacco, which is 1.0 up to 1.5 gram, were extracted in a mixture of methanol dichloromethane with 1:1 volume per volume by stirring for 1 hour at 500 rotations per minute. After the filtration process, the solution was diluted at 50 milliliter, followed by another dilution of 1 milliliter up to 4 milliliter with the same solvent. then 0.3 milliliter, the solutions were injected into GCMS in mentioned conditions. The nicotine content was expressed in milligram per gram of tobacco. Okay, next, the GCMS setup. The GCMS was validated according to the data from the literature. The method is linear over the range of 1.01 to 101.8 microgram per milliliter. The detection limit is 3.6 microgram per milliliter and the quantification limit is 10.8 microgram per milliliter. And the accuracy is high, which is the mean recovery is equal to 100.28%. It is between 99.08 to 100.96%. The GCMS is so precise, which is the RSD value is 0.6560%, while the N is equal to 9. As you can see in the slide, is there a few calculation about the calibration curve equation. Okay, we continue to the results and discussion part. As you can see in the figure 1, the gas chromatogram for Joule's vanilla cigar samples. So the figure 1 presented the chromatogram for the Joule's vanilla cigar sample. From the analysis, there are no additional peaks at the retention time close to that of nicotine, approximately 6.2 minutes. Then we can evaluate nicotine content by using formula milligram nicotine divided with gram tobacco. So as you can see in the formula, N represents the nicotine concentration milligram per milliliter and the T represents the amount of analyzed in tobacco. So as you can see in the formula, N, which is nicotine concentration, multiply with 4 and multiply with 50 and then divided with T represents the amount of tobacco multiply with 1000. So next, you can see in the table ones. The table ones contains the trade name of 31 samples of cigarettes. So the result presented in the table 1 showed that the canned silver cigarette had the lowest nicotine concentration with 10.14 milligram per gram of concentration of nicotine. Meanwhile, the highest concentration was found in the Camel Red with 21.15 milligram per gram. So the highest nicotine was found in the Camel Red brand, while the lowest nicotine concentration is found in the canned silver cigarette. So next, the table 2. The table 2 represents the nicotine content in cigars and pipe tobacco. So from the number 1 up to number 5 is the cigar samples, while the number 6 is tobacco sample. So the nicotine concentration range from 28.38 milligram per gram in amphora pipe tobacco to 13.15 milligram per gram in Scandinavian cafe cream cigars. So as you can see in the table 2, the highest value percentage of RSD is goes to the King Edward cigars of leaf, which is the value of RSD percentage is 0.1306%, while the lowest percentage of RSD is goes to Blackstone Winer, which is 0.0519%.
Table 3 here represents of nicotine content in tobacco leaves. According to the table, nicotine concentration in tobacco leaves from Timisoara was 26.61 mg per gram, and the RSD is 0.0230% and equal to 3. Meanwhile, for LECI is 29.96 mg per gram. The RSD is 0.0832% and equal to 3, which is slightly higher. Next is Table 4, represents the minimum, average, and maximum measurements of nicotine content from cigarettes, cigars, pipe tobacco, and tobacco leaves. As for the highest average nicotine content of 26.79 mg per gram was found in tobacco leaf, while the lowest average of 15.35 mg per gram was found in cigarettes. Quantitative analysis is achieved by using two approaches. Firstly, using the equation of linearity shown above, the concentration in solution, milligram nicotine per milliliter. Secondly, using corresponding concentration in tobacco, milligram nicotine per gram of tobacco, as shown above. As for the comments on the data obtained, the variation of nicotine content among different commercial brands of cigarettes, cigars, pipe tobacco, and tobacco leaf are attributed to different varieties of tobacco used for manufacturing. Also, the filling composition, type of tobacco, use of expanded tobacco, reconstituted tobacco can be vary greatly from brand to brand. The nicotine content of cigarettes may also be influenced by temperature and humidity during transport and storage.
Hello, my name is MEDANG. I am from AS2453S1. For the advantages, GCMS is a highly sensitive method. It can detect nicotine-specific detection, has a lower instrumentation cost, offering high resolution, excellent in reducing signal interference that can bias nicotine value, versatile enough to analyze a wide range of nicotine value in domestic and international of varying complexities, confirm chromatography peak purity in certain highly flavored products. However, it also have a few disadvantages, which is the analysis of nicotine content using GCMS is complicated. The detection limit is too high. Even solid phase extraction result in a detection limit of about 20 ng per ml. There are three factors that we can manipulate to improve the limitation of GCMS. First one is column film thickness. By reducing the column film thickness, we are resulting in reducement in the runtime. The second one is oven temperature RAM rate. We can increase the oven temperature RAM rate that will reduce the runtime. An increase in oven temperature RAM rate from 10 degrees Celsius per minute to 30 degrees Celsius per minute reduce the runtime from 10 minutes to 6 minutes, which is 40% more faster, with no effect on resolution. The run could be made even faster by increasing the oven temperature RAM rate from 30 degrees Celsius per minute to 65 degrees Celsius per minute, reducing the run to 4 minutes, which is 60% more faster overall, with minimal effects on resolution. The last one is the carrier gas flow rate. We can increasing the carrier gas flow rate, which is helium gas, will also reduce the runtime. Increasing helium flow rate allowed for only a small reduction in the runtime. Increasing the helium flow rate to 2.2 ml per minute allowed for a 40% reduction in the runtime, but came at a cost of halving the signal intensity. In my opinion, to get a precise data and result, we should take careful steps when injecting the samples into GCMS. Follow the method and procedure closely when doing the experiment. From the data, we can conclude that nicotine is dangerous and maybe it's bring toxicity to people as it may jeopardize and affect people's health. In conclusion, the content of nicotine from 39 tobacco samples was determined by using a GCMS method validated by the authors. For the 31 tobacco samples corresponding to 15 cigarette brands, the variation limits of the nicotine content were more restricted, which is from 10.14 to 21.15 mg per gram. In comparison with the 6 samples of cigars and pipe tobacco, for which the nicotine content varied in a larger range of value, which is from 13.15 to 28.38 mg per gram. For the 2 samples of tobacco leaf, the nicotine concentration registered very close value. According to the average value, the highest nicotine content was registered in the case of tobacco leaf, which is 26.79 mg per gram, and followed by cigar and pipe tobacco, which is 22 mg per gram, and by cigarette, which is 15.35 mg per gram. That's all from our group. Thank you for watching.